So this MIT guy was on a video talking about airplane crashes and how they figured out all the airplane crash causes and how there hasn't been an airplane crash in the United States since 2003 or something like that. Anyway, so this genius MIT guy, he's like, I was impressed. I was legitimately impressed. He's talking about crash dumps, and everybody knows what. You know what's funny though? Well, anyway, so this genius MIT guy gets on there. He starts saying, "Yeah, I came across this really squirrely stack code." I got to thinking about this. You know what? He probably thought 7FFF was stack. He probably thought that was stack. This genius MIT guy doesn't know what identity map implies. So, like, it's like right up there on the billboard. Ring zero only, identity mapped. So, okay, Mr. Genius MIT guy. Okay, Mr. Genius, if it's identity mapped, how many tasks can have 7FFF as stack? I'll give you a clue. Just one task gets one stack address, another task gets another stack address, and you made a stupid assumption. First of all, I finally figured out what the hell he was. He's talking about me. This genius. So he thinks. Well, okay. Long story short, I put code in addresses under 2,000 under 2 gig. If you know assembly language, there's if you call a function, this is there's only so many addressing modes, and this mode is there's relative 32-bit. The format of the let me go ahead and show you this. Let's go to my compiler assembler directory. And my compiler, let's look for the call opcode in my opcode file. This format is relative 32-bit. The 16-bit is not available. Anyway, there is no relative 64-bit. There's only one instruction that has a 64-bit immediate, and that instruction is you can do a move. You can do a move RAX, and then you can do a 64-bit value, and then you can do a call RAX. But this sucks ass. I don't like that. So what I made a rule. All code goes in the lowest 250 or 2 gig. So let's unassemble. Let's see how it. Okay, so main is okay. Actually, on this machine, I don't have a lot of memory, so I give it less than 2 gig because it's a separate heap. You can't intermix anyway. So this is at 3F. If I had more memory, it would. So the genius didn't know what identity map means. So memrip. So this reports on usage. Okay, so there's the low. Shut up, birds. Anyway, code heap has a certain amount used. The code heap, data heap. This tells what it's used for. There's a hash table on each task. There's some documents, document structures. The big thing is the disk cache. Disk cache is, I forget, what is it, 64 meg? What is it? I forget what this is. I should know. Let's do a quick check. 0x8. Oh. It is 128. So 128. It scales to the amount of memory. It's identity map, so you cannot grow stuff, so it stays the same size. So the stacks are fixed size. The disk cache is fixed size. It kind of sucks, but there's a lot of upside. The upside is it's way simpler and it's faster. You know, it even I go with there's page tables. Oh, where's page tables? Fixed area for page tables. So here's the page tables. I have what do I have? 128 meg, 128, 180,000. 180,000. I could swear. Okay, so 2 meg. I don't have very. I use 2 meg page tables. So, and I always map 128 gig. Damn, there's a lot of numbers to remember. I always map 128 gig of space. You can adjust it if you recompile, change the constant. Anyway, so this is the Adam task. He's the main guy. He has the disk cache. The window manager task has, why doesn't this show? Oh, I didn't fix this report. It's wait a minute, where's the window manager? Oh, there it is. There it is. Okay, here's the window manager. There's a buffer for the screen, several buffers and stuff. That's the graphics code. Okay, what about the RAM disk? Where's the RAM disk? Oh, there it is, RAM disk. RAM disk is 128 gig, 128 meg. So that's how the memory's used. So the lowest two. So let's go to. This is kind of. So I mark the first few pages as not present, so that you get a null dereference crash. There's a guy who likes to brag about making null dereference not crash. So this area has the kernel left over from when it booted. This has son of a bitch, those birds. Anyway, so the code heap, the rest of the memory. So I made a drawing. It's pretty pointless. I used to allocate separate pools for each core, but now all the cores share pools. So there's a code heap in the lowest 2 gig code block pool. Then there's a data block pool for the rest. And the stack comes off the data block pool. Anyway, well, good enough.